Hi everyone, this is Algebra 1, lesson 7-2, multiplying polynomials. Last lesson we learned how to add and subtract polynomials, and we learned how to name them, what polynomials are, and now we're going to multiply them. So in this lesson we'll be able to multiply two polynomials. Let's start with two. Right, let's start with model and discuss. Samantha makes the abstract painting shown using vertical and horizontal lines and 4 colors. Interesting. How can you use mathematics to describe the areas of rectangle 1 and rectangle 2 using expressions? What do you need in order to figure out the area? You need to know the length and the width. Right? And then what do you do with them? You multiply them. So what are you going to do? Find the length and width of the rectangle and multiply. Okay? And then how can you use mathematics to describe the area of rectangle 3? How do you use math to describe the area here? Whatever your length is, if it's in terms of an expression like x plus 2, and that's like 2x minus 1, and you can multiply the expressions, right? So the length of the blue rectangle is composed of 3 segments. Add these segments. 1, 2, 3. 1, 2, 3. And multiply the sum by the width to find the area. So if you don't know these expressions, what if you have the information for this segment and this segment and that segment? What if that's the expression? You add them and then you will multiply the expression for that one as well, right? So whatever information you have, you'll have to multiply your length and width of the rectangle. So it really depends on what information you have. Depending on the information given, we multiply the length and width by finding the expressions for each. If we are given these expressions, we can add the 3 segments for the length and then multiply the sum by the width to find the area. Okay, so let's think about how multiplying polynomials will compare to multiplying integers, and how are they different? They're obviously going to be different. It looks different, but it will be basically similar. Let's look at example 1. Multiply a monomial and a trinomial. What is the product of negative 4x cubed and x squared plus 3x minus 4? So if you have one monomial times a trinomial, then you can just use the distributive property. So it's the same as multiplying a constant, 2 times x plus 1. For example, you use the distributive property to distribute 2 out, right? 2 times x plus 2 times 1. And that's 2x plus 2, right? Do the same thing for the polynomial. You're going to multiply the monomial out to each term in the polynomial. And then you simplify, see if there's any like terms. If not, you just order them in standard form. So the product is negative 4x x to the power 5 minus 12x to the power 4 plus 16x cubed. Okay? And if you multiply monomial by polynomial, your product would be a polynomial. Let's look at try number 1. See if you can find each product. Make sure you use the distributive property and distribute your numbers out. This was just an example, okay? Another example. So look at these steps. Multiply your monomial out with each term. Multiply your constants. And then if you have a negative, then that's your term is negative. Okay, keep your negative sign. And then if you have x to the power of 3 times x, then you have to remember the properties of exponents, right? If you multiply with the same base, then you have to add the powers. Do not multiply the powers. 3 plus 1 is 4, okay? So remember your properties of exponents and use the distributive property to find each product. Pause the video, come back when you're ready for answers. Okay, are you ready? Alright, so let's look how you can figure this out. So you're going to distribute these like this, so you get negative 2x squared times x squared plus negative 2x squared times 3x plus negative 2x squared times 4, right? And then you have negative 2x to the 4th power, and then you have minus 2 times 3 is 6, and then x squared times x is 3, x to the power of 3, and then minus 2 times 4 is 8 times x squared. And writing this in standard form would just be this. So that is your answer. Negative 2x to the 4th power minus 6x cubed minus 8x squared. Part B, you also use the distributive property to distribute negative 4x out in this polynomial. You will get negative 4x times 2x squared plus negative 4x times negative 3x. Do not forget your negative sign. Okay, if you subtract a term, that negative sign comes with that term. Okay, and then plus negative 4x times 5. And that will become negative 8x cubed. Negative times negative is positive, so plus 12x squared. And then minus 5 times 4, 20x. And that's already in standard form. Okay? Check your answers. That was example 1. Use distributive property to multiply them out. Alright, let's look at example 2. Use a table to find the product of polynomials. How is multiplying binomials like multiplying 2-digit numbers? Now we're going to multiply binomials. So let's multiply 15 times 18 and see how it's similar with x plus 5 and x plus 8 using a table. Okay, we're representing actually 15 as x plus 5, where x is 10, right? And that means 18 could be x plus 8 if x is equal to 10, right? So then, if you multiply 15 times 18, you can write 15 times 18 in expanded form as 10 plus 8 and 10 plus 5. You multiply the 10s together to get 100. You multiply 5 and 8 together to get 40. 10 times 8 is 80. 10 times 5 is 50. And if you add them, you get the product. This is just another way to show the product, okay? In that way, when you multiply your binomials, you can also demonstrate it using the same table. Okay, x plus 8 times x plus 5, you can multiply the x terms together, multiply x and 8, you can multiply x and 5, you can multiply 8 and 5. Okay, so you're using the distributive property. You're distributing x with this and this term, and you're distributing 5 with the x and the 5 and the 8. So make sure you're distributing the first two terms evenly throughout the terms in the second polynomial. That's how distributive property works for the binomial. Okay, let's look at an example, another example. What's the area of the green rectangle? So your green rectangle has a length of 2x plus 1, right? This segment plus that segment. And then your width is x plus 3. So in order to figure out the expression for the area, you have to multiply these two expressions. Multiply these two binomials by using a table or using the distributive property. 2x plus 1 times x plus 3. By using distributive property, you distribute 2x over like this. You distribute 1 by that. So 2x times x plus 2x times 3 plus 1 times x plus 1 times 3 would be your answer. And simplify 2x squared plus 6x plus x plus 3 would be your answer, but you need to combine like terms. 6x plus x is 7. And then that's your answer. That's your final solution. Okay? Let's look at try number 2. Find the area of each green rectangle. Okay? Your width and lengths are given with expressions. Please figure out the expressions. Multiply the binomials. Pause the video, come back when you're ready for answers. Okay, are you ready? So part A, you have 2x plus 4 times 5x plus 2. You distribute those binomials. And then you get 2x times 5x plus 2x times 2 plus 4 times 5x plus 4 times 2. And you will get 10x squared plus 4x plus 20x plus 8. Okay, combine like terms, you will get 10x squared plus 24x plus 8 as your final solution. Okay, what about part B? Do the same thing. 7x plus 2 times 2x plus 1 will be 14x squared plus 7x plus 4x plus 2. And so finally, your solution should be 14x squared plus 11x plus 2. Okay? Check your answers. Combine like terms, write it in standard form if you haven't already. Let's look at example 3, multiply binomials in the next page. How can you use distributive property to rewrite 2x plus 4 times x minus 5 as a polynomial? So you will do the distributive property, just like I demonstrated in example 2. And then you will find that the product would be 2x squared minus 6x minus 20 when you combine the like terms. Make sure you use the distributive property thoroughly. Don't forget any terms. Okay? If you have binomial times binomial, you should have 1, 2, 3, 4 different terms when you distribute it out. Then you can combine the like terms and get 3 different terms if nothing gets canceled out. So let's try number 3A and B as well. See if you can use the distributive property. Let's practice more. Okay, are you ready for answers? So using the same method, the product for part A should be 10x squared minus 3x minus 4. Part B should be 6x squared plus 2x minus 20. Okay? Let's look at example 4. Multiply a trinomial and a binomial. How can you use a table to find the product of x squared plus 2x minus 1 and 3x plus 4? Now we're multiplying a trinomial by a binomial. So that's a quadratic trinomial and a linear binomial. You can use the table to multiply each term and add everything and combine the like terms to get your solution. You can also use the distributive property to distribute it out. In this case, you want to distribute these two terms into those terms like that. Okay, and then you add the like terms. So yes, it gets more tedious, but as long as you follow the same steps, it should be fine. All right, let's look at try number 4. Just remember that when you're multiplying trinomial by binomial, you multiply each term of the trinomial by each term of the binomial. Don't forget any term, okay? So let's find each product for parts A and B here. Pause the video, come back when you're ready for answers. Okay, are you ready? So let's distribute this out. 2x times negative 3x squared plus 2x times 4x plus 2x times negative 7 plus negative 5 times negative 3x plus negative 5 times 4x plus negative 5 times negative 7. Okay, now we have 1, 2, 3, 4, 5, 6 terms. And we're going to simplify, combine like terms, and then write it in standard form. Okay, the first term, negative 6x cubed, and then we have 8x squared minus 14x, and then we have positive plus 15x squared minus 20x plus 35. And the like terms are shown. So 8 plus 15, you get 23x squared, and then minus 34x plus 35 would be your answer. All right, what about part B? You also distribute the first term with each of the term in the trinomial, and the second term in the binomial to each term of the trinomial. And then you get negative 3x squared times 2x squared. And then you plus negative 3x squared times 3x. And then you add negative 3x squared times negative 4. Then you add 1 times 2x squared plus 1 times 3x plus 1 times negative 4. And then you simplify. Negative 6x fourth minus 9x cubed plus 12x squared plus 2x squared plus 3x minus 4. Combine like terms, you will get negative 6x to the 4th power minus 9x cubed, no like terms for those, plus 14x squared plus 3x minus 4. No like terms actually, except for the squares. So that should be your final answer. Check your answers. Okay, let's look at example 5. Closure and multiplication. So why is the operation of multiplication closed over the set of polynomials? What is a closure? Okay, so for each example in this lesson, you found the product of two polynomials. In each case, the product has also been a polynomial. So when you think about the operations of a number system, if you say it's closed under multiplication, closed under addition, closed under operation, that means the product stays inside the closed boundary of that same type. So if it says closed, the polynomials are closed under multiplication, that means if you multiply polynomials together, it'll always be polynomial. It will never be a different group of number. Does that make sense? So in each case, the product has also been polynomial. You're going to look at another example. If you multiply this monomial by this trinomial, you get an answer that is also a polynomial. So when you multiply two polynomials, you can see that the sum or difference would be your terms, each of the terms, right? So each term is a real number coefficient multiplied by a variable raised to a whole number exponent. So each term is a monomial. The sum or difference of monomial is a polynomial. So polynomials are closed under multiplication, which means polynomials times polynomials will always be polynomials, is what it means when you say polynomials are closed under multiplication. Okay, that's what it means. So let's look at number 5. Think about why is it important that the product of two polynomials have only one whole number exponents? Why do you think it's important? Think about when it's not the case. If the product does not only have whole numbers, then what happens? Then it's not a polynomial. If it's irrational number, if it makes an irrational number, then it cannot be a polynomial. Okay, this means polynomials would not be closed under multiplication, which is not true, as we looked at it in example 5. It is closed under multiplication. Let's write that down. There. Okay, let's look at application problem in example 6. Apply multiplication of binomials. A smartphone has a screen that has a width of x and a height that is 1.8 times the width. The outer dimensions of the phone are shown. This is the outer dimension, okay? The screen is x by 1.8x. But then the outer dimension is +3 for the length and then +1 for the width, okay? Write an expression for the portion of the phone that is not occupied by the screen. Assume that the phone is rectangular. So assume that it's not round at the edge. We're going to figure out the expression for the area of the whole phone, okay? So we're going to multiply these expressions. Area of the screen would be x times 1.8x, and then area of the phone would be x plus 1 times 1.8x plus 3, and then you would subtract the area of the screen from the area of the phone later in order to figure out the portion of the phone that's not occupied by the screen. Okay, so first you use the distributive property to find the area of the phone and simplify that. And then you're going to subtract the area of the screen from the area of the phone. And you can say that the expression 4.8x plus 3 represents the portion of the phone surface that's not occupied by the screen. So apply all the distributive property and the properties that we learned in the past to figure out each step. So let's look at try number 6. Suppose the height of the phone in example 6 were 1.9 times the width, but all the other conditions were the same instead of 1.8. What expression would represent the area of the phone surface not occupied by the screen? Would it change the whole thing, or could you change a little bit of the numbers there? See if you can figure it out. Come back when you're ready for answers. Okay, are you ready? So instead of 1.8 here, the area of the phone instead would be 1.9x squared plus 4.8x plus 3, okay? You're not multiplying 1.8 with anything else, so you can use 1.9 instead of 1.8 here. And actually, you need to use 1.9 here, so that's 1.9x squared, 1.9x, and then 4.9 actually. So you should have 4.9x plus 3 instead for that one. And so you're going to subtract the area of the screen, which is 1.9x squared, from this polynomial in order to get a little bit different answer. So you can just subtract 1.9x squared, which just gives you 4.9x plus 3. So it's a little bit of difference, but you need to remember that it's 1.9 here for both terms, okay? So 4.9x plus 3 would be your expression. All right, let's summarize our lesson, multiplying polynomials. So if you multiply binomial by binomial, when you multiply horizontally, you would use distributive property to distribute your terms out. When you're multiplying binomial by trinomial, you also use distributive property to multiply your terms of the first binomial to each of the terms in the trinomial, okay? And then you add the like terms, combine them, and you write them in standard form. Vertically, you're doing the same thing except you're solving it vertically. The diagrams may help you picture it in your mind. Okay, that was lesson 7-2, multiplying polynomials. In the next lesson, lesson 3, we'll be learning about multiplying special cases. There are some special cases in multiplying polynomials. We'll continue with the next lesson in the next video. Thanks. Bye.